this lesson, we're going to learn how to blink an LED on the Arduino without using the delay function. Now you might be wondering what use that is, and it's actually quite handy not to use the delay function. That's because the delay function stops everything cold on the Arduino board. That means nothing else can run while that delay function is counting down its time. So imagine, for example, you had a cell phone, and every time you open up an application on your cell phone, you can't receive a call because that application is running. It's kind of like what happens with the delay function. It interrupts everything else, and it just waits out for that delay time. So what we're going to explore in this lesson is ways to get around using that delay function. For this lesson, you'll need an Arduino board. I have the Arduino Uno here. You can use any Arduino or clone. I do recommend sticking with the Arduino name brand for these examples so that we know we're all on the same page. You will need one 220 ohm resistor or thereabouts. You will need an alligator clip to connect leads together, and you will need one LED. Let's go ahead and set up this circuit. I'm going to take my LED, I'm going to take the long pin, also known as the anode of my LED, and I'm going to put it into pin 13 on my Arduino board. Then I'm going to take my resistor, doesn't matter which end, and I'm going to put it into ground on the Arduino, ground being the lowest voltage on the Arduino board. So current will run from higher voltage to lower voltage. And then I'm going to take my alligator clip and connect those two leads together on the LED and the resistor. And then once that's complete, I can plug my Arduino into my computer. Now that we've got the Arduino plugged in, let's go ahead and open up our example here. We're going to go to Digital, Blink Without Delay. Okay, so this example opens up like many of the other examples. We've got a description of the code at the top, commented out, and basically we've already talked about what this program will do. It will blink an LED on pin 13 without using the delay function. We can thank David and Paul for making and modifying this example, and we know it's in the public domain, so we can mess with it as we please. And there's even a URL link in here to check it out on the Arduino website. So the first block of code is where he initializes and declares his variables. I really like what's been done here because he separates constants from non-constant variables. So the first variable he sets up, it's an integer, and it is LED pin, and it's set as pin 13. So he doesn't want that variable to change, so he sets constant in front of integer to qualify the effects of that variable. Then we come down to variables that will change. So the first one is an integer. It's called LED state, and it's equal to low. You'll see how handy this is. You can see low is a keyword, and you'll see how that's used here shortly. Then we have a new data type called long, and we're assigning it to previous millis. So millis, just think of milliseconds, all right? And he set it equal to 0. So an integer is just what it says is an integer, but it doesn't store as many values as a long does. So a long will still only store integer values, but it will store huge numbers comparatively to just integer, which will not store as many numbers. And that's important because if you don't need huge numbers, you want to use integer because you'll take up less space. But if you use a long, you know you're going to use huge numbers, and sometimes you have to do it. And so the software will leave a lot more room for that variable. Okay, so then we come down and we've got one more variable here. We're called interval. It's set to 1,000, and this is going to represent milliseconds, so that's actually 1 second, and it's also a long, so we know that that number will be getting big. So now we come down to our next block of code. It's void setup. Okay, and all we're doing is setting the mode of the pin. So we're using the pin mode function. What pin do we want to set the mode for? LED pin, and if you recall, that was the constant. We set at 13, and we want the mode of that pin to be an output. So that's easy enough. Now we come down to our final block of code here, void loop. Right here, we've got quite a few things in here. So the first line here he's got commented out is basically, this is where you would put the code that you would want to be running all the time. So this would be the meat and potatoes of the code. And what follows and what we'll be talking about is the code that it will take to blink that LED without the delay function. Okay, so the first thing he does is we have yet a new data type here, or a new qualifier rather, and what we're doing is we are setting this variable called current millis. So this is current milliseconds. It is a long, so again, a long is a very large data type, and we're saying that it is unsigned. So normally, when you have a long data type, it will go from like -2 million all the way up to 2 million. It's actually larger than that. I don't know the exact number offhand, but when we say it is unsigned, that means that current millis is going to start at 0 and go all the way to like 4 million and something. So it's this giant positive number, okay? And the reason we want it to be unsigned is because what will happen is that if that number rolls over and it is just a long, it will go and roll over to a negative value and then start counting up to 0 and then go all the way to positive, and then if it fills up, it will go back to negative. Well, we don't want that to happen. When it maxes out to its 4 million number, we want to go back to 0. All right, so you might be wondering, well, geez, what are we going to have to get that? What number would we assign to this variable that it would get up to the 4 millions? And the answer is this function, which is millis. What millis does, and just again, when you see millis, think of milliseconds, is millis will return the value of milliseconds to that variable based on the number of milliseconds since the Arduino has started running. So the second you apply power to your Arduino, it has got a timer that is counting in milliseconds the amount of time that has passed. And if you want to get to that number, you just use the millis function, okay? So, and about after 50 days, this millis function will max out and it will turn over back to 0. Okay, so maybe a little strange. I think you'll get it as you think about it. So now the first thing we run into is a if statement, and the condition that is set is it wants to know is the current millisecond state minus the previous millisecond state greater than interval. Okay, so let's think about this the first time it runs through. So current milliseconds is going to be the time that's captured from the Arduino board in this variable. And then previous milliseconds, we set this equal to 0 up at the top of the sketch when we started out. So basically it wants to know, is this amount of time, so let's say it's been 40 milliseconds since we started the program, okay? It wants to know, is 40 milliseconds greater than interval? Well, if you recall, we set interval equal to 1,000 milliseconds, or 1 second. So at 40 milliseconds into this program, this condition is not met, so the if statement will not run. But 1 second into having plugged the Arduino in, current millis would be 1,000, let's say 1,001. Previous millisecond was 0, so this value is 1,001. It would be greater than interval, and so this code would execute. Okay? So now what we do is we set previous millis equal to current millis. So basically we're saying what is the last time this code executed. So previous millis in this case would equal 1001. Okay, so now the code that we're going to execute is we've got another if statement. And we're going to say if, and the condition is LED state is currently at low. So again, the equal sign is just asking, is LED state equal to low? And if it is, then we're going to set LED state equal to high. Otherwise, we're going to set the LED state equal to low. And then what we do is we just digital write LED pin, that's pin 13 if you recall, and then LED state. Well, so what is LED state? In our case, LED state will be high because we started off with LED state equal to low. All right, up in the if you recall, when we declared LED state, we said LED state is low. So this condition would be met, LED state would be high, and so LED pin 13, LED state, the pin's going to be high. Okay, a little wordy. I think you get the idea. So now we run through the void loop again. Any code up here that you wanted to be running all the time would be running. Once that code finished executing, we'd come down and again we would sign the current milliseconds. So now let's say another second has passed. Okay, so now let's say we're at 2002 milliseconds. So we come to this if statement again. So if current millis, which is 2002, minus previous milliseconds is, so previous milliseconds was set at 1001, theoretically, our last time, right? If that number is greater than the interval, which was 1000, then this code will execute. So you can see that this code in that for loop is going over very rapidly. You know, it's going to be going over several times per millisecond. And so it's not until this condition is met, that enough time has elapsed in milliseconds, that the interval is greater than 1000, that this code will run. And what it's going to do is it's going to check the state of the LED. So last time our LED was high. We left, our LED state was high. So here the if statement, this condition is not met because our LED is high. So else our LED is going to be set low. Alright, and so it's going to turn the LED off. And then it's going to run through that code one more time. It's going to see that the LED is low. It's going to set it to high. And it's going to do this every 1000 milliseconds based on that interval. Alright, so that basically goes through how we're getting around using the delay function. So let's go ahead and verify the code. And let's upload it. And then let's go ahead and take a look at our Arduino and see what it's doing. Alright, another blinking LED. But what's cool about this blinking LED is we are not holding up the program. We can be doing all types of different stuff while that LED is blinking. And that's the whole concept of not using that delay function.